Hello, this is Jonathan Doolin, and I'm continuing a discussion on ResearchGate with Paul Gradenwitz about the differences between the Friedmann-Walker-Robertson-Lemaitre metrics and the Milne cosmology. Paul is very interested in the Milne model, and he thinks there is a property in this model that makes it different from the Friedmann-Walker-Robertson-Lemaitre model that we could compare it with observations. Now, I imagine that is the case. Paul wants my help in exploring this matter in more detail, and no matter what the outcome, he thinks I would be interested in working with him for that, and I do agree. This over here is a diagram that Paul has created, and I had two difficulties with it. One was that the semicircles down here in the spacetime portion of the graph make essentially no sense at all, and the other was that in the circles up above, there really should be no distinction between an equal velocity, equal redshift, and equal distance round. But Paul says he needs these three circles for his case, but in my case, they're not going to be three circles. They're just going to be one circle, I think. I had some difficulty with him because I felt like he was refusing to acknowledge the relativity of simultaneity. Now he says here that he thinks that relativity of simultaneity has a problem but I understand it. Now, it here is a pronoun, so there are two possible interpretations of this sentence. He either thinks that he understands the problem of relativity of simultaneity, or he thinks that he understands the relativity of simultaneity, but that his understanding of relativity has a problem. Anyway, he does agree that if someone was working with special relativity and tried to argue that special relativity had no relativity of simultaneity, they would be wrong. I agree. These two belong to each other. When we are talking about the Milne model, then I want to explore it in detail. I might find that something is in contradiction with observations. That is a valid case. But trying to state that such a model is not using some equations that I like from other theories makes little sense. Okay, so how in this situation would it come into play? If we've got observer O traveling along this world line, then the relativity of simultaneity for him makes events such as this event, let's see, it should come down this way, right? So something like this, these events would be simultaneous for observer O, and maybe these events would be simultaneous for observer O. And so now we could draw another line down there. So those are simultaneous events for observer O. Meanwhile, we can imagine observer A coming up over here, and observer A would say that, say, these events were simultaneous, and these events are simultaneous, and maybe these events are simultaneous. Okay. And of course, for the observer at the origin, which is not labeled O, these events are simultaneous, and these events are simultaneous, and these events are simultaneous. So I was saying neither observer O nor observer A will agree that line now represent a simultaneous locus of events. And he says he agrees with me. He has drawn the diagrams for an observer with the line x equals 0. So yeah, he's using these red lines as the lines of simultaneity. The line x equals ct over 6 is off center. So this is the line, well, no, this is the line x equals ct over 6. That's off center. So the line now for x equals 0 is of course not the line now for O and not for A, but with this line we can orientate ourselves with this line. Okay, moving on. I suggested that the distance, or rather I calculated the distance from here to here as 2.33 billion light years. So the distance, if you come down here to where this line meets this line and use where this line meets this line rather, and use a calculation of 50,000 kilometers per second times time equals 13.7 billion years, then by the time you reach this point, there is 2.33 billion light years between here and here. There's also another 2.33 billion light years between there and there, so a total of about 4.6 billion light years between object A and object B. Now, I'm not sure why, but yeah, he wants to point out that a circle of 1 megaparsec on this diagram is very, very small. I do agree. That's a very, very small dot. This is why I don't want to discuss the obvious variations for observers with different speeds at the same place. I don't think that that's relevant to the question at all. My question that I've asked several times is whether he wants to consider the observer that is going along that space-time diagram, or along that path, or along that path. And I think it's pretty clear at this point that he does want to talk about the guy moving along at that path. But this is the first time it's felt clear that he wants to specify that person. And therefore, it is reasonable to consider things along these lines of simultaneity. Because up to that point, he was kind of ambiguous on that point. All right, here there seem to be two sets of ellipses. One ellipse is in the space part of the diagram, which makes sense. I actually would take that back. I don't think that these entirely make sense because they have the equal velocity, equal redshift, and equal distance. Certainly this one that says equal velocity, it would be equal velocity from that point, but it's certainly not. Sorry, let me write this. Those yellow dots, those would be equal velocity from this point, but certainly not equal velocity from this point. So that suggests that he was using somebody going that way who would regard all of those parts of that explosion as being equal velocity from that point, but obviously not relative to this point. And so he's still, I think he might still be confused about using this point, using this world line or this world line. He, like he said, doesn't want to discuss the obvious variation of 50,000 kilometers per second between a guy going that direction and a guy going that direction. Says he doesn't want to discuss the obvious variation for observers with different speeds at the same place. And they are there. He doesn't care about that for now. But I think he should care because these objects are equal velocity, are equal speeds for the guy going this way, but they are certainly not equal speeds for the guy going this way. Now the equal redshift, which are red, at least have some legitimate possibility of being something that basically, what I would say is if once we take into account that plane of simultaneity, which goes like this, then equal redshift would be, am I drawing that right? Okay, from this point, this and this should be equal redshift. Actually, that line, no, not that, this. Hold on. I'm going to pretend for a second that this diagram was drawn with equipartition in rapidity instead of equipartition in velocity. Because the way it's done, this is 1/6, 2/6, 3/6 is the speed of light, -1/6, -2/6, -3/6, -4/6 the speed of light. What we would do if this was rapidity, it would be 0, hyperbolic tangent of 1/6, hyperbolic tangent of 2/6, hyperbolic tangent of 3/6. And what should happen then is this, what would happen then is that this event would be right along with this event. This is this would be equal rapidity from this line here. And you can take the line of simultaneity and draw it right through there between those 2 points. That's what would happen if everything was split evenly by rapidity. And this would be this point here, and actually, let me highlight those 2 lines. From the point of view of O, this line, AA, and this line, let's call it BB, would be, well, you would see these 2 points at equal distance. You would see the object here and the object here with the same velocity, and you would see the object here and the object here with the same distance and redshift and velocity. And that you wouldn't draw anything down here to represent that. You would draw everything on the light cone itself. Same thing with this line and this line. You would see an event here and here that would be equal distance because they would be along a plane of simultaneity parallel to that one there. And you would see the event there and the event there happening at the same time, or he would see those events happening at the same time. He would see them at equal distance. He would see them at equal redshift because this that trajectory and that trajectory are symmetrical around him. And he would see them at equal distances, velocity and redshift. Let's do another one. Okay, so this line, the particle coming through there and the particle coming through there. And he would see, let's do this one in a kind of reddish color. He would see this event and this event attached to those 2 objects. And those 2 objects would be observed with the same velocity, redshift, and distance as each other. This part, I have no idea what he means. There are no Lorentz transformations. There is a Lorentz transformation because you are going from an observer that has that velocity to an observer that has that velocity. So there is a boost of 50,000 kilometers per second, which is 1/6 the speed of light. Lorentz transformations will change scales, but will not change the order of coordinates. If this coordinate is further away from the observer than this coordinate, it will stay further. And if this coordinate is further away than this coordinate, then they will stay the same. So if one point is closer to the observer and one point is further away, only their absolute distance values have changed. But you'll notice that all of the events over on this side, well, let's just put it this way. The Lorentz transformation is asymmetrical, so it will move events that way. So it stretches out this side as it contracts this side. And likewise, you can come up this way and just expand that out. If it's coming this way there, I should use a different color. That's not showing up at all. All right, so if that's going that way, then adjacent ones are coming up this way, and this will be coming up this way, and this will be coming down this way. Anyway, that transformation, as it does that, will take these lines and flatten them so that these events are stretched in this direction. These events are contracted in this direction. So you can see that it does actually affect, while their absolute distance values have changed. The order is the same if you look in one direction, but the order is not the same symmetrically in the opposite directions. They do have an asymmetry. Paul says he showed me the 3 circles and he wanted to show them in this special order with equal velocity, equal redshift, equal distance. I don't, to me, the way we have things distributed, equal, each one of these, each pair, this one and this one, will have equal velocity, equal radius, equal velocity, equal redshift, equal distance. But that is if you're using this line, or this world line. If you're using this world line, all bets are off. Then maybe you've got something there. From observer O, if he's following this route, both this line, or this group of particles and this group of particles will have a redshift of z equals 0.183. There could be a difference, an anisotropy, if this is just nudged over just a little bit to the right or to the left, and that would be an anisotropy. And regardless of anything else, that stuff doesn't belong in the space-time part of the diagram because those are not parts of the cone in the space-time diagram, because this cone in the space-time diagram are these slanted lines. Cone in the space-space diagram, yes, it's a circle as the top of the cone. All right, thanks for watching. See you next time.